Welcome back to today's Explainer. Let's go ahead and put on our detective hats, because today we're doing a deep dive into permaculture data overlays. We are engineering absolute resilience into our landscapes. Look, we are way past basic gardening here. We're treating ecological design as a rigorous analytical science. We're going to break down how to map invisible forces, resolve critical design conflicts, and essentially use landscape architecture to defend a property against one of nature's most destructive forces, wildfire.
Okay, let's jump right into the blueprint. Today, we're mapping wild energies, analyzing sector conflicts, dissecting the fire behavior triangle, building hydric buffers, creating multi-layered shelter belts, and ultimately designing for true resilience. Let's get to it.
Part 1. Mapping wild energies.
So first things first, we have to realize that a property is never just a blank slate. It is a highly dynamic space, getting constantly bombarded by powerful external forces. To actually understand a site, we rely on a fundamental tool, sector analysis. Basically, this is the identification and mapping of wild, completely uncontrollable external energy vectors, things like sun, wind, and fire, that are sweeping across your site from the outside. Think of these as invisible arrows shooting directly through your property. The big takeaway here is that before you plant a single tree or dig a single trench, you absolutely must map these vectors so you can decide whether to block, channel, or harvest them. You just can't design a solid defense if you don't know where the attack is coming from, right?
Now, it's actually wild to think about how many of these invisible forces are acting on a landscape simultaneously, always overlapping. We're tracking the summer and winter solar arcs, which completely dictate our light and heat. We're zeroing in on dominant wind directions, especially those really hot, drying downslope winds. We map out wildlife and pest migration paths, water flow and flood-prone channels, and, absolutely critical for our analysis today, wildfire approach trajectories. A great designer doesn't just look at the dirt. They are looking at the invisible data flowing right over it.
Part 2. Analyzing sector conflicts. Things get really complicated when these wild energies don't just overlap, but actively conspire to threaten our central living spaces. Seriously, what happens when the hot summer sun, harsh downslope winds, and wildfire vectors all perfectly align from the exact same direction? Well, this is the ultimate design conflict we're unpacking today. How in the world do you protect your home when nature throws a simultaneous wall of wind and fire at it, baked by the intense summer sun? If you put the wrong element in this combined sector, you are literally adding fuel to the fire.
This perfectly highlights the massive difference between just randomly placing elements versus actively using data overlay for a defensive design. Take a vulnerable design, for example. That might look like planting highly resinous, flammable pine trees directly in a hot summer wind sector. By doing that, you've essentially just engineered a fast-burning wind tunnel pointed right at your living room. No way we want that. A resilient design, on the other hand, flips the script. It's about placing a lush, deciduous hardwood canopy right behind a pond in that exact same fire sector. You're actively utilizing the cooling effect of water and that low flammability foliage to build a living biological shield.
Part 3. The fire behavior triangle. To effectively solve this sector conflict, we've got to break down the actual mechanics of how a wildfire travels across a landscape. It comes down to 3 interconnected elements known as the fire behavior triangle. First up is topography. Fire moves incredibly fast uphill because hot, rising air preheats and dries out the vegetation right above it. Next is weather. Hot, downslope winds, think the Santa Ana winds, can carry burning embers for miles ahead of the actual fire front. And finally, fuel. Fuel is the physical medium of combustion. Now here is the real kicker. Since we obviously can't flatten a steep mountain slope and we can't just turn off a hot downslope wind, all of our analytical design has to focus relentlessly on manipulating the fuel. It is literally the only variable we have power over.
And when we talk about managing fuel, we absolutely have to talk about ladder fuels. Think of these as nature's matchsticks. They're basically continuous vertical arrangements of vegetation that allow a low creeping ground fire to climb. It starts in the dry grasses, catches onto the shrubs, jumps up to the low dead branches, and eventually ignites a catastrophic forest canopy fire. If a ground fire hits a ladder fuel and climbs into the canopy, it turns into a crown fire. And those are almost impossible to stop. So our ecological blueprint must systematically sever this vertical connection. Let's look at how spatial zoning builds a concentric fortress of defense, where every single zone has a highly specific engineered job in modifying that fuel load. In permaculture, we organize space into zones based on human interaction. Zone 1, right around the house, is your defensible space.
Clean mode, intensively irrigated, presenting a totally non-flammable barrier. Zone 2 houses our hydric buffers, water features like swales and ponds that keep plant moisture incredibly high to slow the fire down. Out in Zone 3, we use rotational grazing. Sheep and goats act like four-legged weed whackers to consume the brush and break both horizontal and vertical fuel continuity. Then out in Zone 4, we have our shelter belt. This is a managed hardwood canopy designed to block the wind and force any fire down into a damp, low-oxygen understory. Part 4. Building hydric buffers. So instead of just pouring a giant concrete wall, we are going to use water and biology to halt the flames. We do this by deliberately positioning ponds, swales, and graywater diversion channels directly in the path of that dangerous fire sector we mapped earlier. This creates what we call a hydric buffer. The constant hydrologic recharge maintains high plant turgor pressure, which just means the plants are plump, hydrated, and full of water. When a fire hits this zone, it loses its momentum trying to evaporate all the water inside those plants. This is stacking functions at its absolute best. You can position a pond in Zone 2 to bounce warm winter sun right into your home, while it simultaneously serves as a massive emergency fire suppression reservoir for the summer. Now, you might be wondering, where do we get all that water? Check this out. Just 1 inch of rain falling on a 1,000-square-foot roof yields roughly 623 gallons of water. That is huge. This single metric proves that even in pretty dry climates, if we use smart earthworks and catchment systems, we can absolutely capture enough free energy from the sky to keep these hydric buffers completely saturated year-round. We aren't relying on fragile city water grids here. We are engineering the landscape to harvest its very own defense system. Part 5. Multi-layered shelter belts. Once our water strategy is locked in, we have to tackle those harsh, ember-carrying winds. A well-managed Zone 4 shelter belt halts a crown fire in a specific 3-step process. First, we actively manage the space by pruning existing tree limbs up to 10 feet off the ground, totally eliminating those ladder fuels. Second, we establish a dense, closed canopy buffer made of fire-resistant deciduous hardwoods, trees that don't have those highly flammable resins. Third, because that canopy is so incredibly dense, it casts deep shade. That shade completely suppresses the growth of dry, flammable underbrush, forcing any incoming fire down out of the canopy and into a damp, low-oxygen understory where it just loses momentum and starves. Part 6. Designing for resilience. Let's take a step back and look at the incredible byproducts of analyzing and designing your site this methodically. You might be thinking that dedicating all this space just to fire defense is a massive loss of agricultural productivity. Actually, no way. A highly resilient polyculture system doesn't just stop fires. It can yield up to $8,000 per acre. And that's backed up by robust real-world data. We do this by stacking productive elements like fruit, nuts, and grazing livestock right inside those exact same defensive zones. Those goats clearing your ladder fuels, they're providing meat or dairy. That hydric buffer pond is raising fish. The hardwood shelter belt is yielding long-term timber or nuts. Defense and productivity are just beautifully intertwined. I really want to reflect on the core truth we've explored today. Fuel is the physical medium of combustion and is the only side of the triangle that permaculture designers can directly manipulate. We are not helpless victims of the elements. By analyzing the data, truly understanding our wild sectors, and applying strategic design, we take complete control over the fuel on our land. We change the entire narrative from vulnerability to absolute resilience. So, I want to leave you with this thought. Knowing that wild energies are already sweeping across your property right now, how will you overlay your own data to build a resilient, highly productive blueprint? I really hope this explainer leaves you eager to observe your site. Map out those sectors and start engineering an ecosystem that thrives no matter what nature throws its way. Thanks for hanging out with me for this deep dive, and get out there and start mapping those wild energies today.